And now for our final speaker before the break, we have, it's entitled Crisis or Cure, the Divisive Debate on AI's Role in Modern Healing. And it's going to be given by Rohan Goswami, who is the Director for Heart Transplant Research and Innovation at the Mayo Clinic. Rohan has worked with his multidisciplinary team of physicians, data scientists, and research fellows to champion the next generation of clinically relevant AI-based research. His goal is to optimize the human touch with augmented intelligence, improving the lives of patients while creating an equitable, inclusive, and accessible platform. Rohan, over to you.
Okay, well, thanks everybody for joining. I know it's a late afternoon, and you guys have had a lot of different talks about artificial intelligence and technology. My talk is a little bit different, so if we can have the slide up there. Yeah, so my talk is going to be about what I do, which is a heart transplant physician, and how we integrate artificial intelligence into our practice and how it's going to change the future of medicine. And so I always start with a joke. And so this is a really funny one that I thought. This is what most people think about with generative AI and medicine, right? And so why am I talking about AI? Because we have the technology. The question is it equitable and available to all of our patients? And how do we give them access? How do we help people who don't have access to AI, all the cool things we've talked about, that fancy supercomputer he mentioned, and how do we get it to them? And so most people think that the future of AI in medicine is going to be this, where you go into ChatGPT and say, hey, why am I sick? And why am I coughing? And what does this medicine do to me? And it gives you an answer, and you don't have to go to a doctor, and you save your copay, and everything's all good. And so a little bit about me and why I was selected to talk here. I'm from Mayo Clinic in Florida. We are the #1 site in Florida for heart failure and transplantation, all cardiovascular disease. And these are a couple of the papers and things that we've worked on for artificial intelligence, for organ regeneration, for predicting outcomes, and for improving patient survival. And so when we think about artificial intelligence in medicine, we have to think about it with a different lens. We have to use the Benjamin Franklin glasses and think about how we approach healthcare with a different lens. You know, your clients are consumers, my clients are you. And so we have to understand where we get the data from. We have to understand what population builds our models. We have to understand what interactions there are between the 30 years of school that your physician went to and the environment that you live in. And we also have to think about outcomes. What is the outcome that we want to look at with the model that we're building? Is it survival? Is it prediction? Is it drug development? Is it, computer vision and a CT scan? And then how do we define benefit? Can we predict more? Can we improve quality of life? Can we change the diagnostic pathway of a patient? And so I'll start with the burden of healthcare in America. And so 50% nearly is hospital care and physician services per patient in America. That's a lot of money. And my specialty is heart failure, cardiac surgery, and cardiac transplantation. And we talk about the cost of healthcare. It's the #1 reason that patients get hospitalized is cardiovascular disease, both in America and around the world, right? So all the fancy coffee with all the sugar and Splenda and Pepsis that we're drinking, our bodies don't like that. And so the cost of healthcare is something that we need to figure out how to optimize. And when we think about optimization, it's not just in medicine, it's not just in diagnosis, it's not just in testing, but it's also in process optimization, right? So when you go to the doctor's office and you're waiting for me to see you and you have to wait an extra hour, it's probably because 4 patients were delayed because the lab was slow and they couldn't figure out where to go. And so there's a lot of other optimizations that we can do. And so I'm going to talk about the good, the bad, and the ugly of AI in medicine. And we'll start with the good, and we'll end with the ugly. And so when we think about the traditional AI in healthcare, we all know this, right? It's big data, a lot of it. We create a model, and we say, tell me what all this data means and how I'm going to improve my patient's life, how I'm going to get this prediction. We learn from that outcome, we refine the algorithm, and we analyze new data. But that's a very old way of thinking about things. And the reason that's important is because we have a patient at heart, right? So everybody that I see, I'm trying to improve their quality of life and their quantity of life. And so this is where I started bringing AI into my practice. And so this is a real-world example of a patient. So that's a heart ultrasound, kind of like a baby, but that's a heart. The left is on the left, the right is on the right. And this was a 50-year-old lady that I saw. She had had 10 years of heart disease. She had 2 heart attacks. She had open heart surgery. And her heart function was 10% what it should be. Normal is 50%. And 6 different hospitals that she went to said, sorry, you're 50, but you're going to die within a year, and we have nothing to do for you. And so the question was, why did they say that? And why didn't they have options for her? And it's because when people think about patients that are really sick, we don't have enough tools right now to figure out how we can improve their quality of life. And that's because we take a lot of data and we say, hey, all of this data from healthcare, tell me exactly what's going to happen. And you can't do that with medicine because there's too many interactions, there's too many confounding variables, there's too many processes that don't really make sense to a machine. And so what we decided to do is reverse that. And so we said, we know the clinical problem, right? So organ failure is our problem. We know that they're going to either need a heart transplant, an artificial heart, or they're going to go to hospice. We know that outcome. So let's take all of that data and let's reverse engineer it and now look at the machine learning processes that highlight the factors that affect that patient. So now I can say that, okay, I know there's 100,000 patients that had heart transplants, there's 50,000 patients that survived, and there's 30,000 patients that did kind of in the middle. Now, what are all the factors that led up to that from each of my patients, and how do we figure out which feature characterization is better, which AUC is more important, and how do we approach things differently? And so, let me skip past this. And so what did I do? I said, I'm a programmer at heart. I started programming when I was 12 years old, and I said, let's build a neural network and let's figure this out. And so we took a bunch of variables that we had in our patient databases, and I used a convolutional neural network. I had feature characterization of both normal clinical values and the outcome variables. And I looked at traditional and AI-weighted factors, yes, traditional statistical analysis. And we got an AUC of 9.956. And nobody believed me in my institution. Everybody was like, this is too good. This can't be real. And so what did we do? Well, we took that model and we applied it to our patient. And we took that 50-year-old lady. And we saw that she had all these comorbidities, and she had probably an 80% chance of dying under open heart surgery. And we said, let's change the way we look at these factors that she has. Let's look at giving her some support, using a machine to help her body recover and see what we can do over time. And so this lady had an artificial heart that we put in through her artery under her clavicle. She stayed in our hospital for 23 days, and my model that we developed said she was going to recover in 14. And on day 9, we actually started to see heart recovery. And on day 23, she actually had the pump explanted. Her heart function went from 10% to 55%, and she's been out of the hospital for a year now, and she's living a normal life. And so we've improved her survival, where 6 other hospitals in America said she's going to die in a year. And so when we think about the awesome power that AI has, that's a really cool example. It's very unique. It's very specialized. We have both the bridge to medicine and AI with my team. And so now we have to talk about the bad. Because when we talk about artificial intelligence in medicine, we have to think about what can go wrong, right? Because if we make one mistake, somebody might not be in this audience. And I'm from Florida, Mayo Clinic in Florida, and so we'll talk about skin cancer, because this is one of the biggest things that came out of AlexNet in 2012. And so the question is, how can we trust AI? Is it the physician that can't trust the AI, or is it the patient that can't trust what the AI tells it? And there's 2 sides to that coin, right? So if I'm getting these awesome language models that are extracting data and telling me, hey, this patient is going to live or is not going to live if you do or do not do this, can I trust it? And the patient's the same thing, right? If the patient says, hey, my doctor is telling me this is going to work, I'm going to believe him. And so what happens if that goes wrong? And so in Florida, there's a lot of sun. There's a lot of people that don't wear sunscreen, and there's a lot of skin cancer. And so there was a group at a hospital, and they decided to create a computer vision-based skin cancer screening application. And they said, let's train it with normal pathology-associated skin cancers and skin cancers that are malignant or can cause death. And what happened? So they trained this model, right? They had these malignant, really bad, they're going to kill you cancers. and they had these benign lesions that, to me, I'm not a dermatologist, but all that looks exactly the same. And so they created a convolutional neural network. They did unlabeled testing, and they said, wow, this is really fantastic. When we link this to pathology from a biopsy of a skin lesion, it actually works. And so what happened? So they deployed this. And you'll notice in these three pictures, there's something different than in these pictures. And that's the ruler. And machine learning learned that pathologists who think that it's a skin cancer that they're seeing will put a ruler next to the image. And so the machine learning model learned that a ruler means you have skin cancer, not that the pathology that it's associated with is skin cancer. And so there were about 500 people in the clinical trial that this was put on in, and all of them had to go back to the doctor because we weren't sure if they actually had skin cancer or not. Because the ruler is what the machine learning figured out was cancer. So that's the scary part. Now the ugly part is, this is pretty high stakes, right? So we have to understand that data in medicine, data in healthcare is very different than the ones and zeros of e-commerce and transactions and creating a digital twin to go shopping for you, like was talked about this morning. And the problem with data in AI for medicine that really frustrates me is it's all about access, it's all about equity. So most of the data that all the clinical trials for all the medicines that people in this room take, myself included, were built on people that had access to healthcare in the 80s and 90s. And this is a very diverse room, which is awesome, but the clinical trial data is not. It's very whitewashed. It's very old white people. And so you can't really build good models for predicting future outcomes in patients if you don't have data that represents the world that we live in. And so one of the biggest problems that we have is that one incorrect analysis could end up being one patient that's not alive anymore. And that's a big deal. And so when we think about the future of AI, when we think about the future of medicine, when we think about how all of the cool stuff that we're talking about is going to change the world, yeah, we can have self-driving cars and we can have robots that shop for us. But at the end of the day, we all want to be healthy and live a really long life, right? They talked about 21 years to now 79 years for the average lifespan from this morning. And so one thing we have to do is we have to figure out how to get equitable modeling. We have to figure out how to get data that's representative of the people that are in this room and that are in the world. And we have to realize that we need a centralized, independent validation of that data, right? And so at Mayo Clinic, we've partnered and started an organization that's actually just published its first paper, where we're going to talk about how we can actually have a centralized baseline data set for the entire world of medicine. So each specialty, each subject matter will have a baseline data that's been validated, just like AlexNet for all of our imaging, right? That we can reference, and we can test products on, and we can play in the sandbox and not hurt anybody in the real world. And then the next thing we have to do is improve access, right? So one of the things that we learned through COVID was that remote monitoring, remote technologies, Zoom, right, is possible, is feasible, and is pretty reliable. And so now we're going to start doing that with patients. And so one of the examples at Mayo Clinic is we have the hospital at home. So anywhere within the continental continental United States, we can see a patient. We have a device that we can send to them that's the size of a battery charger, or a AAA battery, and it can check your blood pressure, it can check your vitals, it can check your heart rate, it can send it back to me. There's a new company that was just announced at CES, a new technology from a company where it's a drone. And you toss the drone in front of you and it scans your body and it checks your vitals, it can do an eye exam, it can do everything, and there's nobody in front of you. And we can leverage those technologies to help us get data that actually represents the real world. And I really like this quote. You'll always feel fear, but over time you'll realize the only way to truly manage your fear is to broaden your comfort zone. And so I'm really scared about what the future of AI in medicine looks like, even though I'm part of building it. Because there's a lot of people that don't do those checkpoints, that don't say, hey, maybe this data works on this group of people, but it doesn't work on this group of people. And they patent it and they sell it and they make $1 bajillion and they send it out into the world and then they move to Lake Como and they don't care. But for people that are ethical and equitable and want to do the right thing, it's important, the people in this room, to be able to understand how important it is to represent the data for the people that are in this room. So with that, I'll end. This is an image that I actually made on DALL-E, so I thought it was kind of fitting to end this talk. There's my email, and I think I'm way over time. So I don't know if there's time for questions, but I'm always available. Do we have time for questions or no?
Yeah, I think we've got some time for questions. Do we have, we have a question in the front row here.
Lots of hands, cool.
Can my
show my
technical
cool picture that I
friends
built.
hear me? Can we get the image that Rohan made on DALL-E that he mentioned at the end? I didn't think we could see it.
Maybe.
I can see it, but that's not good for these people.
All right, next. Thank you for that. Any other questions? I saw a couple hands.
While we do that, here we go. The lady here has got a question. Oh, you're next. This lady here is next. Go ahead.
Thank you for that talk. I'm Fernanda from AI Governance at MasterCard. You mentioned a very topic dear to my heart of the data voids that exist, for example, for health data, but it happens the same with credit data, for example, with movement that didn't used to own houses or didn't get loans.
Yep.
Do you have any, idea of how we can leverage, for example, people speak about synthetic data being able to maybe fix that problem or at least tackle it, but if you have any other comments on that.
Yeah, so the question for those that couldn't hear it was, how do we get this data that doesn't exist in patients that maybe didn't have access to healthcare? So digital twinning is one of the things that we're doing. So we generate about 10 to 20,000 digital twin patients in our database when we're testing an algorithm, different races, different sexes, different backgrounds. I think one of the biggest things that we have to employ is we have to be able to get access to patients that don't have access, right? So the underserved. One of the easiest ways that we do it at our institution is we took Facebook data and we looked at zip codes and we saw incomes based on those zip codes, and we looked at advertisements for those zip codes, high income versus low income. And we looked at their health correlation, and we found that low-income areas actually get McDonald's and cheeseburger advertisements, and high-income areas get Mercedes and BMW advertisements. And so I think we have to start from a societal standpoint. I think we need to help people understand that public health matters, especially in America. And we need to help people understand that, physicians can be your friends, right? Going to the doctor doesn't mean you're going to get a shot or told that you have bad cholesterol and need to start dieting. It maybe is a different kind of conversation. So I think access, but also using the digital twin environment. Good question, though.
Thank you for that. And next lady.
Hi, I'm Kelly. I'm from North Carolina. And thank you. My sister died, 46 years old, 3 minutes of a heart attack. It happens with women, so thank you for saving that woman. My question is, what are you doing in medicine with AI to, what we say, shift left, to use AI for pre-disease state efforts? You're seeing all these issues going on, but what are you doing for that?
Yeah, well, sorry about your sister, but thanks for the question. So it's all about, I'm sure most people have seen Minority Report, right? The precogs, right? So it's about pre-diagnosis. It's about understanding the factors in our patients, in our environment, in our society that causes disease to progress. And so one of the things that we're doing, one of the things that I'm doing, is looking at genetic markers, looking at proteomics, looking at metabolomics, looking at general stuff that's easily available. I can talk to you about it if you want offline, but we have an EKG model where I can put a 12-lead EKG on you, and I can tell you, do you have heart disease? Do you have liver disease? Do you have kidney disease? What's the likelihood you're going to die in 5 years? And so we're using that in our institution. I think the other thing that's important is being able to distribute that to the world, right? And so, I think as healthcare providers, we need to be advocates for kind of what we were talking about in the first talk, right? There's no open model in healthcare because all the insurance companies want the money. And so we need organizations that are developing these models to be able to give them out for free. And so that's something that we're working on at Mayo Clinic, is trying to create the Mayo Clinic platform where we can distribute this stuff to hospitals around the world. So if you're in France, or if you're in Germany, or if you're in India, you can send me an EKG, it'll run it through my model, and I'll send it back to you. And there's no charge for that. And so I think those are the ways we're going to be able to help build kind of the ecosystem and the foundation for us to improve patients' lives.
Thank you. Great question, a very encouraging answer. I think we have, roving mic, I think we've got a couple of hands here in the back. Keep your hands up if you want to ask a question, just so our microphone can see where. There we go. Thank you. Please stand up as well and say who you are and ask your question. Thank you.
All right. So like, how do you balance self-diagnosis with, like, currently everyone goes to WebMD and looks up their symptoms and come to doctors and they think they have everything. Do you see that as being a problem with AI, or do you think that AI is going to supersede that and be able to actually help and maybe cut down on doctor visits?
Yeah, so great question. The question was, how do I deal with Dr. Google? And so the easy answer is, so it's a double-edged sword. It depends on, can your provider communicate properly with you, or are they just shit scared that you're asking them all these questions that they don't know the answers to? If they can't communicate properly, it's a problem. But if you have a provider who's going to engage in that conversation and say, well, let's talk through your symptoms, let's figure out what you're doing, and make the person feel heard, that's going to be a great positive outcome. I think with AI, the problem is when you train these, large language models and you do 175 billion, model designs and whatever, you may not capture the nuances of, what somebody sees in front of you to what you type into a computer. Perfect example of that is I saw a patient who was sick, was coughing for a long time. And even though I'm a heart transplant doc, we deal with a lot of other crazy stuff. And they came to me because they were short of breath. And they had a little red dot on their skin up here. And I diagnosed them with skin cancer that ChatGPT said, you probably have asthma. And that actually happened 2 weeks ago. So I think that it's important for people who are using ChatGPT, and we need to educate the population to say, hey, this is that thing that says this is not medical advice, but if you feel bad, call 911 or go to your doctor. Like, that should be on all ChatGPT medical questions when it comes out.
Thank you. I know we've got lots of questions, but I've got a lady over here. Please go ahead.
Yes, your thoughts on using large language models for meta-analysis that can be further democratized.
So doctors' notes, so the question was large language models for meta-analyses. My notes are horrible. I only write a note so that somebody else can bill. So if you're extracting it from a physician's note or a provider's note, you're going to get really bad data. So data quality versus what you're going to get at the end isn't going to line up. I think the large language models that are helpful, we get examples from radiology, right? Radiologists are very non-committal, right? They'll say, we think this is this, but correlate clinically, right? We think this patient has pneumonia, even though the lung looks like crap, but we don't know. Ask somebody who's looking at the patient. And so I think if you look at the clinical data and you're able to validate it, or if you have a set way that the data is interpreted in a system, you may be able to use it. But I think if you're doing just note extraction to say, hey, this patient has this diagnosis, I don't think it's going to work.
Thank you very much. Unfortunately, we don't have time for any other questions. I hope, Rohan, you'll make yourself available to anyone who wants to, because it seems like there were lots of hands there. But please give a big round of applause to Rohan Goswami. A fascinating talk. And